Mic test. Okay, for this video, we will move on to the different types of compressors. We have the reciprocating, the rotary screw, and the rotary centrifugal. Again, compressors para under steady state devices yung topic natin. Pero, let's first discuss yung reciprocating compressor. And these are positive displacement machines, meaning that they increase the pressure of the air by reducing its volume. So, they take successive volumes of air which is confined within a closed space and they elevate it to a higher pressure. Paano ginagawa to ng reciprocating compressor? This is done by piston cylinder setup. Okay. So, a piston, cylinder pala yan. So, this is the piston, and then cylinder. So, as you can imagine, the piston will move up and down the cylinder. So, ito yung itsura nung yung reciprocating compressor. Sige, play natin. Yan. For copyright issues, hindi na natin i-play yung video. Okay. So, may different steps yung reciprocating compressor. Sige, dito muna tayo. Meron tayong ito, yung suction. Okay, suction, and then, as you can see, ito po, naka-open. Closed pa muna yung parehong valve. Pero, yung air papasok na siya. And then, next is, naka-ready lang. Naka-ready dyan sa opening. Mag-open yung suction valve. So, pumasok na yung air. Then, ito naka-close pa yung kabilang valve. Next is, magko-close tong suction valve. Mag-open yung discharge valve. Lalabas yung air. And then, next is, expand ng konti, pero parehong closed. Okay? In a PV diagram, ito yung itsura nung cycle na yon, nung isang cycle. So, the first line 1 to 2, all valves are closed. Okay? Pero magko-compress ng konti. So, ito yon. All valves are closed, magko-compress ng konti yung cylinder. Yung piston pala. Then, line 2 to 3, okay? Ito yung discharge line. Oops, teka. Baliktad. So, line 2 to 3, yung laman niya ay okay, wag niyong sundan to. Sorry, ito nga, tama. Ito pala yung line 1 to 2. May konting compression, okay? May compression na nangyayari. Tapos line 2 to 3, mag-open yung discharge line. Okay? Okay? So, next is yung line 3 to 4. Mag-e-expand yung gas na natira. Ito yun. 3 to 4. Okay? 3 to 4. Mali yung arrow. So, may konting expansion na mangyayari. Tapos, 4 to 1, yun na yung intake. Mag-i-intake na yung suction valve. So, cycle siya nangyayari. And then, yung line 1 to 2, adiabatic and isentropic compression siya. Yung line 2 to 3, discharge line. Okay? Line 3 to 4, adiabatic and isentropic expansion. And then, ito, suction line. So, meron tayong names for the different volumes. Yung V1 prime, ito, yung difference ng V1 and V4, yan ay yung actual volume drawn in, okay, at P0 and T0. So, this is the P0. Okay. Yung VD, displacement volume, yan ay yung V1 minus V3. Okay. Clearance volume, yung V3. Okay. V1 is the volume drawn initially. Okay. So, ba't may kailangan ng clearance between the piston and cylinder head? Kung ito yung cylinder, ito yung piston, okay? Pag nag-compress yan, ano ba siya? Sinasagad niya ba sa dulo? Hindi. Lagi siyang may clearance. Hindi siya sasagad sa dulo. Ano yung reason ba't hindi pwede sumagad yung piston sa dulo ng cylinder? Kasi, may possibility na pag sumagad siya, masisira niya yung cylinder. Kaya may clearance volume lagi. Okay? Ito, ba't kasi ano? Yan. Okay, so, isa pang reason, kasi doon sa clearance volume, doon nangyayari yung ignition. Okay, pwedeng doon kasi mangyari yung ignition. Kaya may space, may clearance volume. Tulad dito sa drawing na to, may spark, tapos ito yung clearance volume, doon mangyayari yung combustion. Isa pa nga, yung like yung sinabi ko, pag masyado malakas yung pressure ng piston pataas, tas sumagad siya doon sa cylinder, edi tanggal yung opening. Lilipad yung lid ng piston, yung boundary ng cylinder pala. Oo, matatanggal siya pag masyadong malakas yung piston. Next is, let's derive yung volumetric efficiency. So, using the diagram, okay, volumetric efficiency is the actual volume drawn at P0 over the displacement volume. So, in algebraic terms, in mathematical terms, ito siya, where V1 prime is V1 minus V4. Okay. And let's define yung clearance ratio as V3 over VD. Let's define that na ganon. Rearranging, so ito yung V3 mo. Now, if you will remember yung equations natin sa adiabatic na process, yung relationship ng PV is constant. So, using that relationship, write lang natin yung V3 and V4, saka P3 and P4 na adiabatic kasi yan from 3 to 4, from point 3 to 4 as this one. Then, substituting lang yung V3. Okay, sinubstitute na siya doon in terms of clearance volume. Yan, pinalit lang since P1 equal to P4 and P2 equal to P3. Yan. Tapos, yung kabila naman na process, adiabatic din siya. So, pwede rin siyang i-write na ganyan. Okay? Yan. So, substituting yung mga definitions ng volume natin, we finally arrive with an equation for the volumetric efficiency. Yan. Yung derivation nito, madali lang naman. You can read it sa handout. Okay. If we want the equation to be in terms of pressure. Yan, palitan lang natin ng relationship nung sa adiabatic. Wherein, yung P3 is the discharge pressure, okay, and P4 is the suction pressure. So, emphasizing yung displacement volume, it's the volume swept up by the piston on a single stroke, okay, on a single compression. If we have a single acting engine or compressor, yan, equal lang siya dun sa, ano ba to? Diba ito yung volume ng cylinder? Pi r squared. Kasi, pi r squared yung area. Pag terms of d, d squared over 4, and then times yung height ng cylinder. So, L. Okay, so volume lang yan ng cylinder. Yan. D is diameter of cylinder, L is the length of the stroke of the piston. So, hindi pala yung height ng cylinder kasi nga naman, if ito yung cylinder natin, hindi naman yung buong cylinder yung yung sakop, yung path nung piston mo. So, hindi yung height ng cylinder or length ng cylinder, kundi yung length ng stroke ng piston. Yan. Okay, so correction yan hindi siya yung height or length ng cylinder, pero length siya ng stroke ng piston. What if we have a multi-acting engine or multi-stage compression? So, we just multiply that with the number of, stages. Yan, na N. So, N is the number of diagrams per minute or the number of cycle per minute. Pag sinabi natin na single acting compressor, only one side of the piston is used. So, halimbawa, ito yung cylinder mo, isang side lang yung ginagamit. Pero, pag double acting siya, both sides ginagamit. Ito, saka ito. So, two sides. Ito, one side. Sige, pakita ko lang mabilis. Yan ang double acting compressor. Yan. Pero for copyright issue, wag na natin masyadong ipa-play yung video. Bala ko kasi i-monetize tong video. Joke lang. Reciprocating compressors develop a higher pressure by direct action of the piston on the fluid confined in the cylinder, and the compression is assumed to be adiabatic. Now, if we have a single stage compression, so isang stage lang siya. So, may ito yung fluid drawn in, fluid released out. Do you remember the equation for the work in adiabatic, diba, process? Ito yun. So, we just use that, we adapt the work equation, okay, for the adiabatic process. So, you already know that. Pero, pag multi-stage tayo, we adjust the equation a bit. So, ito yung example ng multi-stage, may connecting rods, okay. So, yan, stage 1, stage 2. Yan ang multi-stage. So, depende sa number of stages, okay, we define compression ratio. It's the ratio between the discharge pressure and the suction pressure. And it's solved by, yan. So, ito yung discharge pressure, ito yung suction pressure, raised to 1 over n. Now, if we have a multi-stage compressor, ito na yung magiging equation ng work natin. Let's assume na intercooling is perfect. So, ano ibig sabihin ng perfect intercooling? Yung intermediate temperatures ay equal lang ay dun sa initial. Yan. Ito. Pag in-assume natin yon na equal yon, we can simplify yung multi-stage compressor work to this equation. Where n is the number of stages. Okay, tapos na yung lecture sa different types, sa reciprocating compressors. Let's move on to the pumps na steady-state device. As mentioned, diba, pumps are used to move liquids. Okay? And we apply the same equations as with compressors, wherein na-simplify natin na ito yung working equation, diba, sa compressor. So, applicable lang din yan sa pumps. Pero, what's the key difference? So, we require the enthalpy of compressed liquids. Pero, diba, wala masyadong data sa compressed or subcooled liquid. Kaya, ina-adapt natin usually yung sa saturated liquid na data. Thus, we can use an alternative form based on the second fundamental property relation. You remember this equation? dH equal to TdS plus VdP. Yan. So, for pumps, we can utilize that equation. At constant entropy, mawawala yung TdS. So, matitira yung dH equal to VdP. Next is we integrate. Okay, we integrate. Yan, yung VdP. So, equal lang yan. Kasi nga, for pumps, diba, we said na delta H yan. Okay? Mass of flowing stream. So, pag isentropic, tas nawala yung ds. Kasi, yung ds naging 0 na. Yung TdS, yung 0. So, integral lang yan ng VdP from P1 to P2. And the usual assumption for liquids is volume is independent of P kasi, diba, usually, pag liquid na siya, kahit hindi masyadong insignificant yung effect nung pressure na dun sa volume ng liquid. Okay? Therefore, ang integral niya ay, so ito, hindi na siya function ng P. So, ang integral nito ay simply V delta P. Ito, V delta P. And calculating the efficiency of pumps, kapareho lang ng equation ng compressor efficiency. Ganun din ang nasa taas, since it's a work requiring device. Yung isentropic delta H, yung nasa taas nung equation kasi mas maliit yon. Okay? Diba? Pag work requiring, mas maliit yung isentropic work required. So, or the minimum work. Okay, so pareho siya ng compressor. Opposite siya ng turbine. Let's move on naman to throttling process. The throttling process naman, ang feature ng throttling process, delta H is 0. Ang tsura niyan, device na yan, ganyan. So, ano nangyayari? Fluid flow through a restriction such as an orifice, partly closed valve, or a porous plug without changes in kinetic energy. So, anong pinaka-effect niya? Pressure drop in the fluid. And then, if Q equal to 0, absence of heat, the process is isentalpic or constant enthalpy. And it's inherently irreversible. Okay. So, yun lang. Pag sinabing throttling process, delta H is 0. Okay, yung sample na to ay, sa ano na lang. Next. Sa next video.